Today's video is on integration using residues. In today's video, we are going to find the poles and the residues at each point of the function z sine z by z minus pi whole cube. See here, from the question, it is clearly given as f of z value as z into sine z by z minus pi whole cube. Now we have to find the poles for the given function. So in order to find the poles, what we have to do? So we have to equate the denominator to 0. So after equating denominator to 0, what happens here? This is z minus pi whole cube is equal to 0. So clearly we got z value as pi. So which is a pole of order 3. Which is a pole of order 3. So we got the pole value as z is equal to pi, which is a pole of order 3. Now we have to find the corresponding residues. So residues for the given pole z is equal to pi. So in order to find the residue, what we have to do? So here is a formula for that. That is residue of f of z. See here, residue of f of z at point z is equal to z naught is equal to 1 by, this is m minus 1 factorial into limit z tends to z naught. This is d by dz power m minus 1. So this is d by dz power m minus 1 into z minus z naught power m into f of z. Clear? So in this, what we have to substitute? So we have to substitute the order value m is equal to 3. And here the pole value z is equal to pi. So if I substitute both, then see what happens here. So this will be residue of f of z. So residue of f of z at the pole value z is equal to pi is equal to 1 by m value is equal to 3. This is 3 minus 1 factorial into limit z tends to z naught. See here, our z naught value is equal to pi. So this is pi. This value is d by dz times of m minus 1. So this value is 3 minus 1 into this is z minus z naught value is pi, and the order value is equal to 3 here. And therefore f of z value is nothing but z sine z. See here, z into sine z by z minus pi whole cube. Z minus pi whole cube. After substituting f of z value, clearly I can cancel z minus pi whole cube from the numerator as well as denominator. So this will be 1 by 2 factorial into, this is limit z tends to pi. This value is d by dz square into the remaining value, that is z into sine z. So this is of the form u by v rule. So this is u and this is v. U we have to make derivative, you have to leave v, plus again we have to leave u and make derivative for v. So in this formula if I apply, so this will be 1 by 2 factorial into, this is limit z tends to pi. So for one time I am making derivative, for z this is 1 and sine z I am leaving, and next one I am leaving z, and for sine z the value here is cos z. And next thing here is, again I have to make a derivative for this. Again I am applying uv rule for this. This is u and this is v, and see this will be 1 by 2 factorial into limit z tends to pi. So this is, so if I apply derivative for sine z, this value will be cos z, and for z value this is 1, and cos z I am leaving, and see here z I am leaving, for cos z the value here is sine z. Clear? And see here the value will be 1 by 2 factorial into, this value is limit z tends to pi. So this is cos z into cos z. So this is 2 cos z minus z into sine z. So in this, if I apply, see here, so if I put z value as pi, then this value will be, so this value will be 1 by 2 factorial into, so this is limit z tends to pi, so this is 2 cos z minus z into, this is value is sine z. And now if I apply z value as pi, so this will be 1 by 2 factorial into, this is cos 2 cos pi minus pi into, this value is pi into sine pi. As you know that cos pi value is minus 1, cos pi value is minus 1, and sine pi value is equal to 0. As we know the values, so this will be 1 by 2 factorial into 2 into minus 1 minus pi times of 0. So this value is minus 2 by 2, and if I cancel, the value here will be, so if the value will be minus 1. Therefore, the residue of f of z at the pole value z is equal to pi value is equal to minus 1. So we got the residue value for the function as minus 1 for the corresponding pole value z is equal to pi. So this is how we have to solve. And see, if you watch this question once again, we have to find the poles and the residues of at each pole of the function, this one. First of all, the function is given like this, and clearly for finding the poles we have to equate the denominator to 0, and z is equal to pi is a pole of order 3. So in order to find the residue, this is the formula. In this formula, if you keep order value m is equal to 3 and the pole value z0 is equal to pi and substitute each and everything, so we have to make a derivative for two times. The first one is you have to use uv rule. For u we have to make a derivative v I left, and again for u I left u, and again I made a derivative for v. So again we have to make another derivative for second time. So after making derivative for second time, we have to substitute the z value as pi. So after keeping z as pi, and see, cos pi value is minus 1 and sin pi value is equal to 0. So after keeping the values, we got the residue values for the corresponding pole value z is equal to 1 is minus 1. Thank you so much for watching, as these videos are very very useful for you. Most important questions, repeatedly asked questions, you can practice well, and you can pass it on to your friends, and definitely you can score more, and you will be best in the class. Thank you so much, and believe me and practice.